Okay, so this is the second video for 7.6. This is called the rational root theorem. When we have these polynomial chains, typically they're set up in some order like this, in which we have the highest degree, and then the next term in the chain is the next degree minus 1, the next degree minus 2, then the next degree minus 3, and this goes so on and so forth until we get to our x to the 0th term, which is just equal to 1, or our constant. So building one of those up, this is what it looks like. So x to the 4th, then x to the 3rd, plus x squared, plus x to the 0, or our constant, which is just equal to 1. As I was telling you guys, I like to use lowercase c or k for the constant, so I'm just going to put k here. When we have these chains, sometimes they're going to have coefficients out in front. We typically call these, or we use the alphabet to do coefficients. So this would be capital A, capital B, capital C, capital D, where these coefficients, they just represent numbers that could be there. So let's build a polynomial that, say, could be p of x equals 2x to the 4th plus 4x to the 3rd plus, I don't know, 2x squared plus x plus our k. Let's let our constant be 10. 10 is my favorite number. Okay, the factor theorem, the one we've been looking at 10 here, and then trying to find what is divisible by 10. If we try to use the factor theorem on this polynomial here, it will not work. And that is because the factor theorem is reserved to when a equals 1, or when this coefficient here, there is none, or there's a hidden 1 here. That's the only time we can use the rational root theorem. If we were to look at a polynomial that doesn't have 1 out in front, okay, then we have to use this thing called the rational root theorem. So let's throw up an example. P of x equals 2x cubed minus x squared minus x minus 3. Okay, and instead of looking at this term right here, since we have something larger than 1 out here in front, we have to look at the fraction created by k over a, where this is our constant and this is our first coefficient. So we're going to look at the fraction of negative 3 over 2. So we're asking what divides negative 3 over 2. And this is the hardest part. Again, this takes a lot of guess and check sometimes. But things that divide into this are plus or minus 1, plus or minus 3 over 1, plus or minus 1/2, and plus or minus 3/2. Okay, and from here we have to play the exact same game that we did before with the factor theorem. We have to check all of these, we have to plug them all in, and we have to see which one will give us a 0. To save us some time on the video, instead of going through all my factors here, I'm going to just plug in the one that works. So this is p over 3 over 2 equals our function here. 3, what we can remember is that this cube, it goes into both pieces here. So this is 3 cubed over 2 cubed, which is 27 over 8 times 2 minus, this is 9 over 4 minus 3/2 minus 3. What I can then start to do is arithmetic massage. These will turn into a 27 over 4 minus 9/4. I need to change this into fourths. This is a good review on fractions. So this is 9/4 minus 3. If I want to put 3 in terms of fourths, I have to multiply by 4 over 4. Just a fancy way of multiplying by 1. This will give me 12/4. This might be a little dusty in our memories. This is going to be some serious review back to fractions and all those good things. When we do all this, we end up getting 0 as the answer, which is exactly what we need. Okay, once you've distinguished that 3/2 is a factor and that it makes the polynomial 0, we used to write our factors like this, plus or minus, that'd be minus 3/2. We can't write our factors like this when we're dealing with the rational root theorem. We want to get rid of any fractions. So if you recall, the fraction we were looking at is just p of k over a. And the way that we'll write the factors is ax minus k, or plus k, plus or minus. So for this problem, this would be 2x minus 3. If you want to check to make sure you're writing it the correct way, you should plug in this number and be able to get 0. So let's check it. 2 times 3/2 minus 3. These will cancel. This becomes 3 minus 3, which equals 0. So writing it like this is the right way to write our factor. Again, this is the fraction k over a, and we'll write our factor as ax plus or minus k. So the a can go in front and the k can go next. Just like the factor theorem, you're going to have to do the long division on this. However, when you use synthetic division, there has to be a 1 as the lead coefficient, like this. And since we have a 2 out here, we can't use synthetic division. So I'm going to have to go old school and do some long division here. So to do that, I'm going to ask this times what will make a 2x cubed. I know that that just requires an x squared. X squared times 2x will give me 2x cubed. However, I need to put in the other part, so x squared times negative 3x is negative 3x squared. I'm going to do the subtraction here. And you have to remember that this distributes to both pieces. So this is actually 2x minus, or 2x cubed minus 2x cubed is 0x cubed. Negative x minus a negative 3x squared is really saying x squared plus, or negative x squared plus 3x squared, which is 2x squared. The next part is to bring down our other pieces with the sign. Okay, now I ask, 2x times what will give me x squared? That's just going to require an x. In fact, I need a negative x. Oh, no, I'm sorry. I'm trying to make just 2x squared. So, positive x. X times 2x is 2x squared. X times negative 3 is negative 3x. I'm going to do the subtraction here. When I do the subtraction, I have to remember that this distributes to both pieces inside the parentheses. So now I have 2x squared minus 2x squared is 0x squared. Negative x minus a negative 3x is x plus 3x is going to give me 2x. I need to bring down my last piece with the sign. And it looks like I have 2x minus 3. What times 2x minus 3 will give me 2x minus 3? Or what times 2x will give me 2x? The only answer for that is 1. 1 times 2x is 2x. 1 times negative 3 is negative 3. I'm going to subtract these. I'll end up getting 0 as the answer. You guys can't really see that, but it's there. 0. See? 0. Cool. Okay, again, we should be getting no remainder, so this is exactly what we want. We are almost done at this point. The last step is we have to present this like a mathematician would. So we write our polynomial that we started with, and then we write our factor, which was 2x minus 3. And then we write what we got in our division, which is x squared plus x plus 1. At this point, we're pretty much done. We have to ask, is this factorable? In which the answer is no. No, it's not. Needed to think about that for a second. I don't see this as being factorable. Therefore, this would be our final answer here. Okay, again, these kind of just take a long time. There's a process and a procedure. Once we're comfortable with the process and the procedure, we can start to move on and not practice as much. But we got to practice these for these next few days, okay? Questions, comments, please let me know. We'll see you all tomorrow.